What makes more sense, God or atheism? We live in a remarkable galaxy, don't we? A wonderful universe of beauty in our Milky Way, which is one of the many galaxies in the universe. It has been estimated that there's between 100 and 400 billion stars. All of these operating, as we can see on the screen, through laws of orbit, laws of order, gravity. It has precision, it has predictability, mathematics. It seems to be behind all of the interactions. And inside this Milky Way, one of these stars, just one of the 400 billion stars, is our sun. And around the sun orbits a tiny planet that we call Earth. A unique planet. It has a unique atmosphere. It contains water. It sits in what they call the Goldilocks zone, where it's not too cold and it's not too hot. The perfect temperature range, so that everything isn't boiled and melted, and also it is not frozen and stuck like ice, although it does seem of recent events that that's a bit strange, isn't it? Before we've obviously been suffering from the ice recently. But the point is that there's no other planet like the blue marble that we have as our home. And then when we look inside and go along the earth, we see life. We see life in the rivers and the seas. We see birds in the trees. We see animals. We see insects. We see seasons, summer, winter, spring and autumn. We see the moon, which operates the tidal systems around the earth. We see water cycles, we see wind cycles, we see systems that all seem to be at work. And the life on Earth is incredibly complex, isn't it? Thousands and thousands of complex organisms, all governed by order, food chains, organization, systems at work in life. And, of course, we have the complexity of humans. You know, breathing, reproduction, all those things around our animal life, and those systems that are at work in our bloodstreams and everything there is to do with us. It all seems, doesn't it? It all seems at face value to be highly complex and ordered. So I think it's only natural for human beings to ask the question, well, where did all this come from? Where did all this beauty, this life, this complexity, these varieties, where did they all come from? And of course, in terms of this evening's talk, we're going to be looking at two positions on this, two worldviews, so to speak. The first is the theist's worldview. The theist is somebody who believes in the existence of God. And I'm here representing the Christadelphian community, and we would position ourselves as theists. We believe that behind the complexity of life, there is an intelligent designer, a God who has a purpose for the universe, and particularly for the earth and the human race that exists upon it. But then there is another position, the position of the atheist. An atheist is somebody who does not believe in the existence of God. They don't believe in a force, a supernatural force higher than the natural order of things. And so what the atheist would say is that the variety around us, the life that we see, it has all kind of occurred somehow by natural causes. It has occurred unconsciously, unguidedly, almost by chance, they might say. Now, I want to make a very clear point at the outset of this talk. I cannot prove, beyond any shadow of a doubt to you this evening, that a God exists, just as an atheist could not prove that a God does not exist. What I am looking to do this evening, with your permission, is to present some facts which hopefully you will agree with me that it makes more sense to be a theist, to believe in a God, than to believe in not a God, is that a thing, but to be an atheist. But the point I want to make is that both positions, an atheist and a theist, both require some form of faith. both require some form of belief system. Ultimately, ladies and gentlemen, it will be your choice, and that is entirely up to you. It's a very personal question whether you believe in God or not. It is a choice, but as I say, I will be making the case this evening that it makes more sense to be a theist than an atheist. Now, the claim of everything coming around by natural processes was first made plausible, if we put it like that, by Charles Darwin. His ideas, basically stemming from this book, The Origin of the Species, published in 1859, paved a way for mankind to kind of accept this idea that God was not needed, that there was no need for a being superior to the natural order of things. His ideology gave rise to the popularity of modern atheism that we see in our country and across the world today. And so what we want to do is to actually examine a little bit of what Charles Darwin mentioned in this book, The Origin of Species. There's my copy if anyone wants to look at it afterwards. As I say, he published this in 1859. He'd actually accumulated a number of ideas from other scientists around. And his basic idea, this is from one of his notepads, his basic idea was that life all stemmed from a common ancestor. And that over long periods of time, that this life would change and diversity would exist because of these little changes that would take place over long periods of time. And so branches of development would stem out of the original kind of common ancestor. And so you see here, he says, I think, and that's his explanation. He's obviously sketching it and trying to explain it to somebody at the time. Darwin's idea had two kind of main arguments. The first is that he postulated that as an organism changes during their life in order to adapt to its environment, those changes were passed on to its offspring. So Darwin didn't use this example, but I think it's used in some school textbooks even still today. A giraffe will stretch up to reach leaves, and it would develop, according to his theory, a little bit of a neck that was slightly higher than its ancestors, and the population around it wouldn't have quite a tall a neck as the giraffe that was really stretching high, and then its offspring would adapt, would have this trait carried down to its offspring, and then eventually, through the second point he called natural selection, the ones with the higher necks would ultimately survive and become stronger and better animals than the weaker ones who didn't have taller necks, and so the weaker ones over time would die out. And when we kind of apply that principle across multiple populations across the globe, it seems to be a plausible explanation as to why there might be all these varieties if, of course, there is no God. And so these observable variations and adaptations, Darwin saw them in like finches in these birds. He kind of postulated that if we go back in time billions of years, then all these little tiny changes might amalgamate to massive changes. And so what we have is what we call microevolution, which are minor variations, and macroevolution, which is where those variations over long periods of time would become completely new animals. And these ideas are still with us today. We'll have a little look at the history and how it developed in science, but this is kind of a modern example of how the evolutionist and therefore the atheist would potentially look at life, how it started. He thought from some sort of primordial soup, this kind of idea that there were these kind of lakes around the earth, and somehow chemicals formed and eventually gave form to the first cell that replicated, and then life started to develop through this idea of inheritance of traits, and then natural selection working on those. And so they've attempted to map out all of how things could develop from fish, amphibians, right the way through. So this was Darwin's kind of idea, the tree of life, and everything stemming from one one kind of cell, replicating cell. And this caught on, of course. It required and it meant that there was no need for God. There was no need for man to answer to anything higher than just themselves, because this is an unconscious, automatic process. So as we say, just to kind of really try and make that clear, Darwin suggested that the origin of life kind of came from a primordial soup, almost by accident, something kind of formed for the first time. And then life developed from there on in as these little organisms inherited what he called acquired characteristics, as they did something in their kind of environment that helped them adapt and change, and that was inherited down through time. And then the strong ones survived and the weak ones died out. The survival of the fittest, natural selection. Now, I just want to make a point that natural selection, no theist would have a problem with. So, if you imagine we were going to naturally select all the red cars that were in the car park, that would mean the red cars would survive and everything else would die out. Nobody has a problem with the idea that the strong survive and the weak will not survive. So we have no problem with the idea of natural selection, strong organisms, strong animals surviving and weaker ones dying out. No problem at all. But the other two is where there is what we call science friction. There's a little bit of debate, of course. Now, Darwin himself, in his book, he has a whole section which he entitled Difficulties of the Theory. It's a very interesting chapter to read, chapter 6. And in it, he actually says this. He says, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down, but I can find no such case. So Darwin said, look, if you can show me something that couldn't have adapted and evolved through these kind of inherited traits, then my theory would break down. But he didn't know of one. But in his day, technology was quite limited. They'd understood what a cell was, but they just thought these were just kind of the way everything's made up. But what happened since then was, of course, the simple cell has been looked at in much, much more detail. The simple cell is way more complex than anyone had ever imagined. And I don't think, I'm going to make the point that I don't think that this could just assemble by accident in some sort of primordial soup when you consider the complexity of this cell. Because all of the things I'm going to speak to you about now, all of them have to be in existence at exactly the same time, otherwise none of them will be of any use whatsoever. So consider this. We have the nucleus of the cell, which does lots of things, but amongst them, it is kind of like the data bank, the library, if you like, of the cell. And it actually makes, and I'm going to probably pronounce this wrong, so forgive my ignorance, ribosomes, which you can see are down here. How do you say it? Ribosomes. Thank you for your help. You might need to give me some more in a bit. So, ribosomes. So it creates ribosomes. And ribosomes, interestingly, are like little factories. Ribosomes create proteins. What are proteins? Well, they're molecules which, when connected together, can transport or become part of the actual cell itself and build that cell. We've got mitochondria, which are like little power stations. And these produce the cell's energy, which helps to kind of get things going. There's loads of other things like this endoplasmic I can't say that one either, reticulum. Thank you very much. Which is really interesting because what that does is it sorts the proteins. It's kind of like a delivery service. And it packages these proteins into different kind of combinations and sends them around the cell so that the cell can start doing what it needs to do. This is irreducibly complex, this system. It's like a mini city just in the simple cell. We've got the cell membrane as well. I find that fascinating. That lets some stuff in, but other stuff it doesn't let in. They haven't quite worked out exactly how that works and how it knows to do that yet. But the point we're trying to make here is these things are incredibly complex. It's what we call irreducibly complex, because if you remove one thing, say you remove the nucleus, no one in the city would know what to do. If you removed the factory that creates the energy, nothing would work. If you removed the thing that created the proteins, nothing would be built. So all of these systems, these complex factories, they all have to be in place for this to work. If you remove one part, the whole system falls down. And if you think that was interesting, you see that little tail at the end of the cell there, that's called a flagellum. And that is, when I found out about this, it blew my mind. It is a biological rotary motor, a bit like an outboard motor in a boat that we would see today. It consists of a number of receptors which initially detect the concentrations of a variety of chemicals around the cell. Secondary components extract information from these sensors that in turn are used to input to a gradient sensing mechanism. The output of this mechanism is used to drive a set of constant protein powers reversible rotary motors which transfer their energy through a microscopic drive and propel the flagella forwards, sometimes between 30,000 to 100,000 RPM. Incredible piece of mechanical machinery, one might say, except it's organic, except we find it in most cells. And again, these complex elements that all have to be in place, they all do something different, but they all have to be in place at the same time for the whole thing to work. It is what we call irreducible complexity. If you take one bit out, the flagellum motor wouldn't work, the cell wouldn't be able to get to where it needs to get to. And if you thought, well, that was interesting, how about this? Inside the cell, when the scientists, obviously this is past Darwin's day, they got better and better microscopes which revealed some of this complexity which Darwin didn't have any idea about. And when they looked inside the nucleus, one of the things they found when they got right in was these things called chromosomes. And when they started to zoom right into these chromosomes and they could start to unpackage them, you see how they found these weird helix things, strands, that wrap themselves around these chromosomes. And what they worked out was that this was none other than the language, if you like, the thinking, the program which ran the cell. And so in 1953, it was discovered that this was what they called DNA. I'm not even going to try and pronounce DNA. The most complex molecule, ladies and gentlemen, in the whole universe known to man. It's a language which exists inside these chromosome strands. And I think it would be highly improbable for DNA, the building blocks of life, to just have assembled randomly. And I'll explain why in a moment. It's a genetic code, and it contains every detail, this code, of all physical beings. For example, your eye color, the structure of your organs, the shape and function of your cells, your skeletal system, all of these things are contained in DNA. It's an enormous set of instructions, and it fits within the cell. It routinely directs the formation of the entire body, starting with just a single fertilized egg. It's the language for life. Now, it's been predicted, the complexity of the language that's in there, that they've mapped most of it out. And they think that if we were to write out the meaning of these things, it would actually be the equivalent of us having 1,000 books, and each of those books containing 500 pages of very small, closely printed type. That's the amount of information in just one cell of your body, all programmed into sections called genes. And there's sections that are turned off, and there's sections that are turned on in the DNA, from what I can understand. The human cell contains 23 pairs of these chromosomes, or 46 chromosomes in total. Each chromosome is formed by these two strands of DNA, and they're bonded together to make those helixes that you can see on the screen. It was discovered by these two chaps, James Watson and Francis Crick. Now, apparently, this is just some interesting facts that I find quite fascinating. Apparently, your DNA is arranged in that coil, in kind of coils of coils of coils, which allows it to be compacted into a very small space, just 6 microns across. But apparently, if I took Dave and I found a cell and I took out one of these strands of DNA, bear in mind how small it is, if we unraveled it all, it would approximately come to about 2 meters. That's from one cell, a very small strand. And so the complexity of that, apparently basically, according to this quote I've got here, if we actually took all of David's cells in his whole body and pieced them all together and strung out the DNA, it would actually be about, according to this, twice the diameter of the solar system in length of information. That is how complex it is. That's from sciencefocus.com. And from conception to birth, a baby adds about 15,000 cells per minute, each cell more complex than a space shuttle, as we've seen. Imagine that, 15,000 a minute as a baby grows, as its cells multiply. The complexity of that is just mind-boggling, isn't it? And you've got to bear in mind that when a new cell grows, it divides into 2 and replicates itself. And what happens is the DNA strand copies itself into its replicated new cell. And so you've got 2 replicated cells. It duplicates that DNA molecule. All of the information for the whole structure of the being is then transferred to that new cell, but that new cell somehow knows exactly where it is, what it needs to do its little piece of function, and then it's going to replicate itself again, and that cell, the next cell, and so on and so on and so forth. Absolutely mind-boggling how life works. And although the workings are chemical, ladies and gentlemen, those chemical workings of the cell are controlled by information which does not reside in the atoms and molecules of that cell. Because how does that cell itself know what to do next? Something has set this in motion. Something has given this information to the world so that life could exist. Only DNA reproduces DNA. No one has ever kind of come across DNA just randomly generating itself. DNA only exists from other DNA. And so when this was discovered, it was also discovered that in your DNA, that actually is what you inherit from your ancestors. You do not actually acquire traits from anything that you do in your life. So, for example, if you push weights and become really strong, it does not mean that your son will also become strong, or your daughter, because that is part of the DNA. And this was discovered by scientists. And so this idea that Darwin had of the inheritance of acquired characteristics, the inheritance, for example, of being able to swim or dance or sing, these traits have no connection with the genetic elements of your body. And so this idea of inherited traits don't actually pass on. What is passed on is the genetic code that is in your cells. Now remember that Darwin, his idea, his mechanism for new things coming along was this whole idea of the inheritance of acquired characteristics. But modern science has actually disproved that. He had to have some new way of new things popping up so that natural selection could select from it. But that is not a thing, it turns out. And so a new idea had to be promoted, because of course we couldn't just now Darwinism was debunked, switch back to theism. Oh no. A new idea came along, which was the idea of mutation. And so what we call neo-Darwinism was born. And the idea of mutation was that hey, what happens is in the DNA, a mutation suddenly takes place. And this idea is that kind of these mutations, which are caused by like radiation or chemicals or some external force that kind of changes the DNA somehow, that this is the mechanism by which new things kind of come up and then natural selection can start working upon it. It's called, as I say, neo-Darwinism. The modern synthesis is also known as. But there's a major problem with this idea for the neo-Darwinist. Because the big question really is can mutations really create new information? This is where the debate rages. Mutations that are caused by effects such as radiation or chemicals, they can cause permanent damage to a DNA code by genetic accident, but do they actually do anything helpful? And as I've mentioned, apparently, some of the genetic information that we carry with us is turned off. And when it comes across radiation or whatever, sometimes it can be turned back on. But that doesn't necessarily mean that new things are evolving out of it. Apparently, when the information in the DNA is decompressed, deciphers, revealed, reconnected, or unscrambled, or scrambled, it can make these changes. But I want to suggest to you that this cannot be used as evidence for evolution, since the information is already there in the DNA strand. And the majority, if not all, depending on your point of view, of mutations that have ever been witnessed are damaging. They take information away from something that's already there. They damage it, they scramble it. So this isn't really an explanation of how this language of DNA, written in this book, so to speak, or library of 1,000 books inside one single cell, came about in the first place. It's not actually an explanation for the origins of life and new information. It's a scrambling of genetic information which already is in existence. So it's not proven to generate new life. It's not proven to actually generate anything fresh and new in the system of things. It is it's kind of a false mechanism. It requires faith that may actually be the case. And also, likewise, faith that in the first place, DNA could form almost randomly by accident in some sort of primordial soup, that the soup could come alive and eventually become everything that we see today. Now, ladies and gentlemen, let me just put a point of logic across to you. There's a bunch of books there. Say we took one of those books. Would we ever imagine that one of those books came about by complete pure accident? That like the colours on the covers, the cyan, magenta, yellow and black kind of magically formed, that the pages and the letters inside the book all formed into an intelligible amount of information, that the book numbers were all there, giving us an understanding and an indication of the order, and that the book somehow has become bound and useful and intelligent. Could all of that happen by accident? And of course we'd all say, absolutely not. Of course it couldn't happen by accident. Why are you asking this stupid question, Matt? Well, I think when we look at this, what it tells us is that information comes from intelligence. If we were to take one of those books and scramble it, or even scramble part of it, it would become pretty useless. And this is exactly how people far more intelligent than me, describe DNA. After they deciphered it, this is what the Telegraph said in 2003, scientists have said that they've finished writing the book of life, the 3 billion letters of DNA that make up the human genome. Professor Alan Bradley, director of the Wellcome Trust Sanger Institute in Hixton, Cambridgeshire, which carried out nearly a third of the work, said, completing the human genome is a vital step on a long road, but the eventual health benefits could be phenomenal. Just one part of this work, the sequencing of chromosome 20, has already accelerated the search for genes involved in diabetes, leukemia, and childhood eczema. We shouldn't expect immediate major breakthroughs, but there is no doubt we have embarked on one of the most exciting chapters of the book of life. Your DNA is like a book. It contains information that's set up in the right order. It actually has letters, a language, structure, and all of these things, I would suggest to you, indicate that it makes more sense to believe in a force higher than these laws than it does to assume that the laws of nature randomly sprung up some sort of complex molecule like DNA, which, as we said, is only a small part of the complexity of that cell, that all has to be there, all at the same time, for any of it to work. What did Darwin say? He said, if you could show me something that couldn't gradually kind of come about, then my whole theory would be debunked. And I think that is what DNA has actually done. So when we look at things, this is the logic. When we look at a book, it tells us, but behind that book, there's an intelligent designer. And my suggestion to you then is, why don't you say the same thing when it comes to intelligent design in regards to DNA? Design has behind it purpose. Now, as you can tell from my very terrible pronunciation of the areas of the cell, I am not a microbiologist, and that's not my area of expertise. However, I am a designer. And I can tell you now that design always has a purpose. When we design something, for example, a website, there is a purpose in it. There's an end picture in mind. It has actually been said that the creative process is actually, things are created actually twice in the creative process. Firstly, in the mind of the creator, to kind of give an end picture, and then secondly, in reality. If you think about a building, for example, the blueprint and the architecture and the kind of the mechanical engineering, all of that is created first, and then the steps leading up to that, in reality, it then takes place. You have to kind of have a purpose to a language, a purpose to design, in order for it to then complete itself. Brother Patrick's here, he'll know exactly what happens when that process is not followed. Absolute chaos takes place. I'm not saying that you would do that, Patrick, but you know as well as I do, that if no end purpose is in mind, it can become problematic. And also the other thing to consider is when that kind of end-to-end process is set up and everybody understands where to go and the laws and the systems are in place to get to that end result, what happens, for example, with web code, which has been laid out for us to produce websites, what happens if some of that got scrambled on the way? Well, I'd like to think that suddenly a shopping basket would suddenly be created or a new forum would be created, but that never ever happens. What happens is the whole thing breaks down, and even a full stop out of place, in human code at least, can result in catastrophe. Scramble code and it brings chaos. Scramble the design process and you don't get anything of purpose or use at the end. So purpose and design are connected. We have evidence, I would suggest, in DNA of design, of an intelligence, of an end in sight, of that tiny cell when it replicates, in terms of when you're just a tiny thing in your mummy's tummy, that can eventually, the information in that tiny cell can eventually grow to a full baby. That is an end picture in mind from the information contained in just the first human cell. And for that reason, ladies and gentlemen, I would suggest to you it makes far more sense to be a theist than an atheist, because intelligence is behind language. Intelligence is behind the information in every single cell of your being. And so the choice is yours, to stand with the theists and to choose that side of things, that God creates everything for that purpose, that there is a God, or to stand with the atheists, that everything happened unconsciously by chance, the probability of which I would suggest is nigh on impossible. Now, I'm here representing the Christadelphians, so I can't really sit down until I tell you a little bit about why we believe that the God of the Bible is that intelligent designer. There's 1,000 gods out there, isn't there, in paganism, in Hinduism, in Buddhism, and all sorts of other isms. So why would you accept the God of the Bible as being that intelligent designer? Now, I would suggest to you that if there is a God, that he is going to have revealed himself. As I've said, there's purpose in design. What purpose would there be of designing this wonder of creation and setting it off and then not having anything to do with it? It would make more sense if that God has revealed himself. So we go up a stage in our exploration. We then have to look at all the religions of the world, which we're not going to do this evening, you'll be pleased to know. I'm just going to present to you the positive case for the God of the Bible. There's loads of things we could look at. We could look at archaeology, we could look at the intricate nature of the Bible and how it all interlinks, undesigned coincidences. But for me, personally, the wonder of Bible prophecy shows that the God of the Bible is unlike any of the other gods presented in any of the other religious texts. The Quran, for example, does not have prophecy like the Bible. The Buddhists, the pagan religions, the Hindu texts do not predict the future. This is what the God of the Bible says. He says, I am God, and there is none like me, declaring the end from the beginning, and from ancient times the things that are not yet done. That's a testable hypothesis, isn't it? Either there's evidence in the Bible of future events being predicted, and therefore this is the God that created all things, or not. Let me just give you a couple of examples. We do look at these in detail from this platform, don't we? This is Daniel chapter 2, the dream of empires, also known as Nebuchadnezzar's dream, which predicts the amazing inheritance and overthrow of the empires of the world down through time. From the time of Nebuchadnezzar, around 600 BC, to the Persians, through to the Greeks, through to the Romans. Hundreds of thousands of people affected. History from 600 BC right up until today and beyond. The prediction that the Roman Empire would not give way to another empire, like another empire wouldn't come on and take on the territory and the power of the Roman Empire. And that the Roman Empire would divide into this feet phase of the image. Absolutely wonderful things, ladies and gentlemen. How about this one, the nation of Israel? The Bible predicts their scattering. 2,000 years ago that happened when the Romans dispersed the Jewish nation around AD 70 from their land. The Bible predicts their survival. Unlike all the other nations that the Romans dispersed, the Jews became and remained a distinctive people, and they survived all of the attempts to absolutely eradicate them. Think of the Holocaust, for example. And finally, the Bible also predicts their regathering back to their land. We've seen this, 1948, 1967. Against all the odds, Israel has survived. And I would suggest this is evidence of the truth of the God of the Bible, who is outside of human control. Let's open our Bibles just to kind of finish. I want to show you what the Bible does say about the creation. So if we just flick over to Genesis chapter 1, the first chapter of the Bible, we read, in the beginning God created the heaven and the earth, in verse 1 of Genesis chapter 1. And when you read the Bible as history, you find out that this event took place approximately 6,000 years ago. The designer designed and created the heavens and the earth and all the things that we see around us. This creation, according to the Bible, is 6,000 years old. And we read, if you look at verse 24, for example, that God said, let the earth bring forth a living creature after his kind, cattle and creeping thing and beast of the earth after his kind. And it was so. And God made the beast of the earth after his kind, and cattle after their kind, and everything that creepeth upon the earth after his kind. And God saw that it was good. So the claim of the Bible then is that God is this intelligent designer who created animals and life forms after his kind. That doesn't mean that God created something in a static way. He creates kinds of animals. I think there's flex in the genome. We accept there's adaptations, there's minor variations. But I don't think you're ever going to see a hamster eventually turn into a whale, because the hamster is hamster kind and the whale is whale kind. And that's the claim of the Bible. Sorry, I don't mean to be flippant, but that's the truth. I don't think on the claim of the Bible that that's the case. And observable science backs this up. Nobody has ever seen one animal change into something completely different. That requires faith. That is a religion based on atheism, that there is no God. God says he has a purpose. He says in Isaiah 45, "For thus saith the Lord that created the heavens, God himself, that formed the earth and made it. He hath established it. He created it not in vain. He formed it to be inhabited. I am the Lord, and there is none else." God has created the earth to be inhabited. He has a purpose with the earth. When you read your Bible, you realize that the human race was disobedient to God through Adam and Eve, and that because of sin, they were made mortal and had this bias towards sin, which causes death. And so they became mortal. And this mortality was inherited by the rest of the human race as time goes on. But we also find out that God in his love and his mercy has designed a way of salvation. That he sent his Son, the Lord Jesus Christ, to show forth powerful principles of his rightness. And that Jesus was, although the Son of God, also a man, with the same problem of mortality and this temptation to sin, except he did not sin. He overcame it. And he died on the cross some 2,000 years ago. And he did this to show that mankind's punishment was just and right, that we are rightly associated with death. But because Christ did not sin, God in his love raised him from the dead and rewarded him with eternal life. And on the basis of the rightness of those things, God has been calling people out to have a knowledge of this. And the lovely thing about the Bible is that what it teaches is that if we believe these things and show our beliefs in the way that we live in baptism, that we too can share in the reward of Christ. And that ultimately God's plan with this earth is to fill this earth with his glory, a coming kingdom which will be set up on the earth. And so that's our position as Christadelphians and as theists. And obviously we've touched on those very lofty things very quickly, but I hope we've done enough this evening to whet your appetite so that you might come and learn more of these things, because we'd be absolutely delighted to share these things a little bit more with you as you explore them. So thank you very much this evening, and I hope you'll agree with me that it does indeed make far more sense to believe in God than to be an atheist. Thank you.